In 1977, humanity launched Voyager 1 and 2, aiming to explore the giant outer planets during a rare planetary alignment. Using gravity assists, these probes embarked on a grand tour, venturing farther than any human-made object before. Despite their 1970s technology, the Voyagers survived radiation storms and the unknown, sending back data that transformed our understanding of the solar system. After their planetary missions, they pressed on into interstellar space, crossing the heliopause to sample the Milky Way itself. Today, both Voyagers are silent ambassadors, carrying our story into the cosmic ocean, embodying our drive to explore and connect with the universe. The first stop on Voyager's grand tour was the giant planet Jupiter, a world of immense storms and swirling clouds. As Voyager approached, it sent back breathtaking images that revealed Jupiter's turbulent atmosphere in unprecedented detail, showing us a planet alive with motion and color. Among the most striking features was the Great Red Spot, a colossal storm larger than Earth itself, raging for centuries. Voyager's cameras captured the churning clouds and the dynamic, ever-changing nature of this iconic storm, giving scientists new insights into Jupiter's powerful weather systems. But perhaps the most astonishing discovery came from Jupiter's moon Io. Voyager revealed a world unlike any other, with hundreds of active volcanoes spewing lava and sulfur into space. This was the first time active volcanism had ever been observed beyond Earth, completely transforming our understanding of what moons could be. Using Jupiter's immense gravity as a slingshot, the Voyager probes accelerated toward Saturn, embarking on the next leg of their journey. When they arrived, Saturn's beauty was revealed in stunning detail. Its intricate rings, composed of countless icy particles, and its mysterious shepherd moons that sculpt and maintain the ring's delicate structure. Voyager also turned its gaze to Titan, Saturn's largest moon, shrouded in a thick orange haze. The spacecraft's instruments detected a dense, nitrogen-rich atmosphere, hinting at complex organic chemistry, and raising tantalizing questions about whether Titan might resemble a primordial Earth. These encounters transformed what were once distant points of light into vibrant, dynamic worlds. Each planet and moon revealed its own unique weather, geology, and mysteries, from Jupiter's storms to Saturn's rings and Titan's enigmatic surface. The wealth of data returned by Voyager fundamentally rewrote our understanding of the outer solar system, challenging old theories and inspiring new ones. Scientists pored over the images and measurements, uncovering surprises at every turn. Voyager's journey was more than just a photographic mission. It was a deep dive into the nature of planetary systems, revealing the complexity and diversity of worlds far from our own. The mission set the stage for future exploration, showing us how much there was still to learn. Thanks to Voyager, the outer planets became real, tangible places in our imagination and in science, forever changing our cosmic perspective and reminding us of the wonders that await in the vastness of space. And Voyager 2 alone continued to Uranus, the only probe to visit this tilted blue-green world. It discovered new moons, faint rings, and a bizarre, corkscrewing magnetosphere, challenging our theories of planetary fields. Neptune, the final stop, stunned scientists with its deep blue color, supersonic winds, and the Great Dark Spot. Triton, Neptune's moon, revealed active geysers and a frozen, dynamic surface. Even in the solar system's coldest reaches, Voyager found geological activity. With Neptune's flyby, Voyager 2 completed an unprecedented tour, leaving a legacy of discovery unlikely to be repeated. The grand tour revealed a solar system far stranger and more vibrant than we ever imagined. Each Voyager spacecraft carries a remarkable artifact, the Golden Record. This is not just a scientific instrument, but a time capsule. A message in a bottle cast into the cosmic ocean, intended for any intelligent life that might one day discover it, no matter how distant, in time or space. The Golden Record is a testament to our desire to reach out beyond our world, to communicate across the vastness of the universe. Curated by a team led by astronomer Carl Sagan, the Golden Record contains a carefully chosen collection of images, natural sounds, and music from around the globe. It also features greetings spoken in 55 different languages, each one offering a glimpse into the diversity and richness of life on Earth. The record paints a vivid portrait of our planet's cultures, landscapes, and the many ways we express ourselves through art, science, and language. The purpose of the Golden Record is twofold. It is both a hopeful gesture to the cosmos, an invitation to connect with unknown civilizations, and a mirror held up to ourselves. It asks us to reflect on who we are, what we value, and what we wish to share with the universe. The odds of the record ever being found are incredibly small. The Voyager spacecraft are now traveling through interstellar space, and it will be at least 40,000 years before either comes close to another star. Yet, the act of sending this message is a profound statement of hope and imagination. Creating the Golden Record challenged us to consider what it truly means to be human. Scientists, artists, and thinkers from around the world collaborated to decide what message we would send to the universe. What sounds, images, and ideas best represent our species and our home. The Golden Record stands as a symbol of our curiosity, our creativity, and our longing to connect, even across unimaginable distances and timescales. It is a gesture of goodwill, reaching out to the unknown with open hands. In many ways, the true audience for the Golden Record may be ourselves. It reminds us of our shared hopes, dreams, and the things that unite us as a global community. It encourages us to look beyond our differences and see the beauty in our collective story. Voyager's message is one of unity, curiosity, and the enduring human spirit, a reminder that even as we journey into the unknown, we carry with us the best of who we are. For decades, Voyager's signals were steady and predictable, until recently. Suddenly, Voyager 1's transmission changed, displaying a structured, repeating pattern unlike any previous data. Engineers suspected a malfunction given the probe's age and exposure to cosmic rays. Yet the pattern didn't match any known failure mode. It was as if the probe was speaking a new language. The anomaly spread through the scientific community, sparking intrigue and speculation. Was it a technical glitch, or had something altered the signal on its journey home? The mystery deepened, and the world watched as scientists searched for answers. A whisper from the void had captured our imagination. Traditional analysis couldn't crack the signal's complexity, so NASA turned to artificial intelligence. Machine learning algorithms, trained on decades of Voyager data, searched for patterns invisible to humans. The AI found the signal didn't match any known malfunction. Instead, it revealed a structured, layered message. This was no random glitch. The data was organized, intricate, and coherent. The AI transformed the garbled transmission into a clear, though still mysterious structure. The challenge shifted from fixing a probe to deciphering a message. Scientists now faced a puzzle that blurred the line between engineering and cryptography. The question was no longer, is Voyager broken, but what is this message trying to tell us? As a physicist, skepticism is my default. When faced with the unknown, my first instinct is to search for the simplest explanation: a malfunction, a glitch, a trick of our instruments. After all, history is filled with false alarms and misread signals. The universe is a noisy place, and our technology, as advanced as it is, remains vulnerable to error. So, when a strange signal appears, the likeliest cause is still a technical hiccup, not a message from the stars. Yet science demands that we keep our minds open to the extraordinary. What if just this once the anomaly isn't a mistake? What if the signal we detected was deliberately altered, crafted by an intelligence far beyond our own? The possibility, however remote, is too important to ignore. We must ask, are we truly alone, or is someone, or something, reaching out across the cosmic void? Consider Voyager, our silent ambassador, drifting endlessly through the galaxy. It carries with it the hopes and dreams of humanity, a message in a bottle cast into the cosmic ocean. Out there, in the vastness, it could have been intercepted by an advanced intelligence, one curious enough to investigate this tiny probe from a distant world. Imagine such a civilization, far older and wiser than ours, discovering Voyager. They might study its construction, decode the Golden Record, and ponder the strange beings who sent it. Perhaps in response, they decide to send us a greeting, one that speaks not in words, but in the language of the universe itself. Our AI, tirelessly sifting through the data, uncovers something remarkable: complex nested patterns that defy random chance. These are not the fingerprints of nature or machine error, but the hallmarks of intention, of intelligence. It's as if someone out there is trying to get our attention, using the only medium we all share: mathematics. Mathematics is the true universal language. Across the cosmos, prime numbers and mathematical constants remain unchanged. A cosmic hello might begin with a sequence of primes, or the digits of pi, patterns that any civilization, no matter how alien, would recognize as a sign of intelligence. The odds of alien contact are slim, perhaps vanishingly so, but they are not zero. In a universe as vast and ancient as ours, even the rarest possibilities deserve our attention. To ignore them would be to close our minds to the greatest mystery of all. Are we alone? If this signal is real, if it truly comes from another intelligence, it would make us profound discovery in human history. Solitary observers, the participants in the cosmic conversation, our sense of isolation would end. Please let us wonder. For now, we balance caution with wonder, listening intently to a whisper from the stars. Each night as our instruments scan the heavens, we wait, hoping for a reply, and daring to dream that we are not alone after all. Science demands we exhaust all natural explanations before embracing the extraordinary. The simplest answer is still a rare malfunction, perhaps triggered by cosmic rays or decades of wear. The signal could have been distorted during its journey, passing through unknown interstellar phenomena. Even our ground stations could be at fault. Software bugs or interference might create artificial patterns. Scientists are rigorously checking every possibility, using multiple observatories to confirm the anomaly. The process is slow and methodical, but essential to true discovery. Only after ruling out every mundane cause can we consider the extraordinary. Until then, the mystery remains unsolved, a testament to the rigor of science. Whatever the signal's origin, Voyager's legacy is secure. These twin probes have transformed our view of the solar system and become our first emissaries to the stars. Their endurance is a tribute to human ingenuity and curiosity. Soon their power will fade and they'll drift silently through the galaxy, ancient relics of a young civilization. The golden records they carry will outlast us, a message of hope in the darkness. Voyager's discoveries paved the way for missions to Jupiter, Saturn, Pluto, and beyond. The universe still holds surprises, as even our oldest explorers can show us something new. Voyager's story urges us to keep exploring, questioning, and reaching for the unknown. The next great discovery awaits somewhere in the vast frontier of space.